Welcome to AI Frontiers. This episode presents a day in the life of computer vision, synthesizing 80 research papers from December 20th, 2025. The focus is the field's evolution from basic perception toward visual cognition. A central problem being tackled is visual hallucination. For example, when shown a photo of a sparrow, an AI might confidently identify it as a pileated woodpecker. This is not lying, it is visual hallucination. The same error in medical scans or self-driving cars could be catastrophic. Today's research tackles this fundamental reliability challenge. The field has evolved. For decades, machines were taught narrow, specialized vision, acting as factory inspectors or radiologists. Now, the goal is to build visual polymaths through fusion with large language models. The objective is cognitive scene comprehension, not just labeling. Today's papers map this transition from perception to cognition. Current models can be thought of as Renaissance scholars. They must converse, reason, and imagine beyond image edges. The tagline CSCV now stands for Cognitive Scene Comprehension. The field has built a powerful engine in multimodal models and is now obsessively tuning it to be faster, more reliable, and more thoughtful. The first major theme is efficiency and scalability. The current standard approach dumps all image tokens into the model at once, which is chaotic and expensive. New methods like Delta-LLaVA introduce a base-then-specialize approach, akin to an expert summarizer creating a concise brief first. IPCV prunes redundant tokens by checking if neighbors can reconstruct them. Adaptive-VoCo acts like a variable bitrate encoder for vision, compressing simple images heavily while retaining detail in complex scenes. The second theme is mitigating hallucination, turning forensic science on AI's fabrications. Hallucination remains the Achilles heel for reliability. Research by Liu and colleagues identified a pattern called SAD, where subdominant token accumulation leads to a dominant but wrong answer, like a game of telephone inside the model. Another paper, SmartSight, uses the collapse of a model's attention across video frames as a self-diagnostic signal to filter unreliable answers. The field is moving from mere observation to surgical intervention. The third theme is reasoning beyond the frame, teaching models to be visual detectives. This pushes models from being catalogers to scene detectives. The OpenView benchmark tests out-of-view understanding. M3-VERSE creates a spot-the-difference challenge for videos over time. Text2Graph VPR converts scenes into textual graphs of object relationships for robotic navigation. Models are learning occlusion, causality, and dynamic spatial intelligence. The key finding is that token efficiency is achievable without major performance loss. The old assumption was that more visual data and tokens were needed for better performance. Work from Delta-LLaVA, IPCV, and Adaptive-VoCo shatters this. They demonstrate training speedups of 1.5 times to 4 times, and inference up to 55% faster, all while matching benchmark scores. This proves the bottleneck is often in algorithms, not just hardware. Another paradigm-challenging finding is that reasoning can surpass human-defined labels. The Finder system performs vocabulary-free, fine-grained recognition. It does not use predefined bird names or scientific taxonomy. Instead, it generates descriptive labels through reasoning and clusters them to discover its own categories. Astonishingly, it outperformed a zero-shot model that was given the correct scientific names. The paper of the day is Thinking Beyond Labels, Vocabulary-Free Fine-Grained Recognition Using Reasoning-Augmented LMMs by Dmitry Demidov and colleagues. This work is a quiet rebellion against foundational AI assumptions. Its objective is to build a fully automated vocabulary-free recognition system. It uses a 3-step process: describe images with a reasoning model, judge and organize the descriptions, then classify. The system bootstraps its own ontology purely from visual evidence, challenging anthropocentric machine learning. Why does Finder's discovery matter? Human labels can be arbitrary or focus on features not always clearly visible. Finder latches onto consistently visible discriminative features. The model's invented categories proved more effective for recognition than established scientific names. This suggests machines might discover visual distinctions humans have overlooked, developing their own language of seeing. It positions reasoning as a core mechanism for knowledge discovery. Looking ahead, future directions include adaptive architectures that dynamically allocate computational power. Research into internal model mechanics will turn black boxes into interpretable glass boxes. The focus will expand to temporal and causal reasoning, understanding video as a narrative of events. There will be deepening investment in specialized, trustworthy AI for critical domains. This evolution is akin to moving from building an aircraft's wings to perfecting its navigation and safety systems. In conclusion, the field is maturing at a staggering pace, moving beyond brute force accuracy to tackle human-centric problems of efficiency, trust, and understanding. Models are learning frugality, self-critique, and reasoning about the unseen. The journey from pixels to perception is largely won. The new journey, from perception to visual cognition, is now fully underway, driven by many simultaneous research efforts. This presentation was synthesized using the GPT model DeepSeek. Audio narration was generated via DeepGram text-to-speech synthesis. Visual elements were created using OpenAI's image generation. The content underwent human expert review for accuracy and coherence, though some oversights may still exist. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archive preprint server.